everyone, and welcome to section 4.2, where we are going to learn about reflections. So first thing, let's define a couple things about reflections. Reflection is a rigid transformation that uses a line like a mirror to reflect an image. So it's an isometric transformation, and the size and the shape doesn't change. It just moves it around, and it can flip it so that it looks like a mirror image of the original image. And then the line of reflection is a line that acts as the mirror for a reflection. Some things we need to know about reflections is that if the point is not on the line of reflection, such as this blue point P here, we have a line of reflection that's right here, line M, then the line of reflection is the perpendicular bisector to the point. So that means that every point that is reflected along this line is perpendicular to this line. So we can figure out point P because it's going to be equidistant from our line of reflection as well as perpendicular to that line of reflection. The second property we need to know is if the point is on the line of reflection, then the reflected point is also on the line. So if our original point is on line M, then the reflected point is on line M. So let's do a few examples of both of these properties here. The first one is we have triangle KLM, and we want to reflect it over the line y equals 1. So they want us to draw in the line of reflection and then draw the reflected image. So let me get a straight edge here. We are going to locate y equals 1. Y equals 1 is a horizontal line, so let's go ahead and sketch that in. And we will have a line right here. So that's the line we're going to reflect over. That's where we are taking our mirror point at. And every point is going to reflect about this. So point M is on the line. So that means we're going to reflect point M prime on the line based on that previous property. And then we have point L, which is 1, 2, 3 blocks away, a distance of 3 units away from our y equals 1 line. So we need to go the same distance and perpendicular to this line of reflection. Lucky for us, we're on a horizontal line, so everything vertical from this point is perpendicular. So if we are a distance of 3 units away for L, that means L prime is 3 units away on the other side of this line of reflection. So this is L prime right there at the point -7, -2. K prime will be a vertical distance down the same distance away from our y equals 1 line. So we are 1, 2, 3, 4, 5, 6, 7 units away. That means we have to go 7 down. 1, 2, 3, 4, 5, 6, 7. This is K prime. If we connect all of our points, we will get our reflected triangle. And you can always double check everything. If you take your straight edge and you take a look, L and L prime are perpendicular to our line of reflection. Same thing with K and K prime. They are both perpendicular to that line of reflection. So this green triangle here is our K prime, L prime, M prime. Second example has us reflecting over a vertical line. So we are going to draw in the line x equals -3. Now we are cutting through our pre-image here. And same rules apply. So we have a vertical line here. Everything we are reflecting is going to be on the horizontal. So M is a distance of 1 unit away over to the right, so we want to reflect 1 unit away to the left. So we have M prime. L is 1, 2, 3, 4 units away to the left, so we want 4 units to the right. 1, 2, 3, 4. This would give us L prime. K is 1 unit away to the left, so we want to reflect 1 unit to the right to get our K prime. Again, connect our points using a straight edge. That's not a very good line right there. Let's fix that. Try and fix it. There we go. And K prime, L prime, M prime is the reflected image. Color that in so it's easier to see. But again, if you take your straight edge and you connect K prime to K, you have that perpendicular distance, or that perpendicular line, and the same distance from the line of reflection. Same thing goes with L and M. There are some lines of reflection that are very common and really easy to figure out where your reflected point is going to be, because it has a formula for it. So anything that's reflected about the x-axis, you can actually take the original point, your xy point, and keep the x value and take the opposite sign of the y value. So in the formula it has a negative sign, but it doesn't mean that you have a negative value in that coordinate point. It means that you're going to take the opposite sign. So if we originally had a positive value, say 4, 2, our reflected point would then be 4, negative 2. But if we started with something like 3, negative 5, then our reflected point would be 3, take the opposite sign of negative, which is positive, so it would be 3, positive 5. So be careful with those negatives. It doesn't mean that you have a negative in the coordinate point itself. You're just working with the opposite sign. So the reflection about the y-axis says to take your original point, take the opposite sign. For the reflected point, take the opposite sign of your x and keep your y value. If we're looking at a reflection about the y equals x line, which is that diagonal line on a coordinate plane, all you have to do is switch your x and y positions. So your original point turns into a new point with y comma x. Reflection about the negative x, which is, again, that diagonal line on your coordinate point, but with a negative slope. You take your original x and y, you put them in their opposite positions, and you take the opposite signs. And then finally, the reflection about the origin, you take your original point, x, y, and you just take the opposite sign of each of those, and you'll get your new coordinate point. So let's do an example here. And again, we're given triangle KLM. And this time we're going to reflect about the y equals x line. So let's draw in that line so we can get a nice visual of what we are reflecting over, because it's easier for our brain to think about what we have to do when we don't have to think about an invisible line. So, excuse me, the rule, I rewrote it here. It says take your x, y, and just flip-flop their positions so that your new coordinate point is y comma x. So here k is negative 4, 8, so k prime is going to be 8, negative 4, because we're keeping their signs. We don't have any location or notation here to take the opposite sign. L prime is then 4, negative 7, and M prime is 1, negative 2. So let's go ahead and plot these 3 points on our coordinate plane here. So K prime is 8 to the right, 4 down. L prime is 4 to the right, 7 down. And M prime is 1 to the right, 2 down. So let's connect those points after I mark them, since I forgot to do that. And we can have our reflected image. And we can just double check by eyeballing it with a straight edge to see if all of our points are perpendicular to the line of reflection and approximately equidistant from there, just by eyeballing. It should be equidistant. So M and M prime, looks like those are perpendicular to this orange line here, the line of reflection. K and K prime, those look perpendicular and equidistant. And then L and L prime look perpendicular and equidistant. So this green triangle here is our reflected image. The next type of reflection we're going to talk about is a glide reflection, and that is a transformation involving a translation followed by a reflection. So we are going to move our image left or right, and then we're going to reflect along some line that they tell us. So let's do an example, and we're asked to graph triangle ABC, which I already did, and its image after the glide reflection. So we first need to do a translation, so that's what they're giving us, and that's on top, so we will do that first, followed by a reflection, and then they tell us to reflect it over the y-axis. So let's write out our points here. We have point A is 3, 2, B is 6, 3, and C is 7, 1. First thing what they want us to do is apply this rule. So we want to take our original xy, and it's going to yield a new xy point of x, and then take your original y and subtract 6. So that means we take our original x of 3, our y value minus 6. So A prime is then 3, negative 4. B prime, applying that rule, keep our x value and take y minus 6, so we have 3 minus 6, gives us a B prime value of 6, negative 3. And then our C point, keep the x, 1 minus 6, gives us C prime of 7, negative 5. After that, they want us to reflect over the y-axis. From just a moment ago, you learned that a reflection over the y-axis follows the rule of x comma y yields negative x, y, or the opposite sign of x, y. So we are going to work now with our A prime, B prime, C prime, because those are the points that we're going to reflect. Because they have been translated, now we want to reflect them. So A prime is 3, negative 4. Our A double prime, because now it's moved a second time, so we need that double prime. Take the opposite sign of your x value, so this turns into negative 3. Keep your y value. So we have negative 4. We are going to reflect B prime, which is 6, negative 3. And it's going to give us B double prime, keep our x of 6. Opposite sign of our x is negative 6. Keep our y, which is negative 3. And then finally, C prime has the point 7, negative 5. And we need to reflect that. So we will get opposite sign, so negative 7, negative 5. And let's plot these points. Plot these 3 points right here, because those are our points after the translation and after the reflection. So A double prime is 3 to the left, 4 down. B double prime is 6 to the left and 3 down. C double prime is 7 to the left, 5 down. Connect our points. And that is our glide reflection of triangle ABC. Line symmetry. A figure in the plane has line symmetry when the figure can be mapped onto itself by reflection in a line. And that line is the line of symmetry, a line of reflection that maps a figure onto itself. So let's draw in the lines of symmetry we have three figures here, and if there are any lines of symmetry. For a heart, we've all drawn a heart for a very long time, and starting in elementary school, maybe preschool, or even before that, by taking a piece of paper and folding it in half and drawing this right hand side, and then we'd cut it out and we'd open it up and we'd get this shape. That line that you would have, that fold in the paper, is your line of symmetry. A square has quite a few lines of symmetry. We can fold it in half this way. Well, that's a little bit off center. We can fold it in half this way. We can also fold a square from corner to corner and have the exact same image, the same triangle on the left and right, or top and bottom, whatever you want to consider that. And if we do the exact same thing for the opposite corners, we have that there. Lines of symmetry should all go directly through the middle, but I drew this one slightly off center. So there's 4 lines of symmetry. So here for the heart we have 1 line, 4 lines for our square. For a parallelogram, there's no way to fold this to map it on itself. If we try to fold it here, this part, this angle folds down, this will fold there, it's not going to map. If we try to go through the diagonal here, this corner actually ends up there, and this one down here. Let me cut one out for you so I can actually show you. Okay, I cut one out. So we've got a parallelogram here. If we try to fold it from this vertice to this vertice, we get, this is not very easy to do. It's easier to talk about than do. We get something that looks like this. So this doesn't map on itself. If we try to fold from the vertices that are farther apart, we get something that looks like this. So again, our corners aren't matched up. If we try to fold directly in the middle here, corners don't match up. Try and fold directly in the center here, corners don't match up. So a parallelogram has no lines of symmetry. So sometimes you might have to actually cut out the figures so you can figure this out. Sometimes they're easier to see because they're more familiar to you. But that concludes today's lesson, section 4.2 on reflections, where you learned the rules for reflecting over x-axes, y-axes, y equals x, y equals negative x, and the origin. And then you learned about glide reflections, where that's a reflection when you have a translation, then a reflection. And then also we've concluded with these lines of symmetry and how to figure out how many lines of symmetry there are. Thanks for listening, and I will talk to you soon.